The needs of data center used to train a modern LLM is, a few months of, I don't know, the studio LA, right? So it's pretty serious.
Wow.
Right? The modern data centers are about 2 to 3%, I think, of global energy consumption. And
Okay.
AI will probably be the lion's share of that, like in 2 to 3 years from now.
Hey everybody, and welcome to another episode of Deep Learning with PolyAI's podcast, the only podcast that promises to hand out Brussels sprouts this Halloween. No, it's not going to happen. We want good candy. What's your favorite candy, Nikola?
Not Brussels sprouts. Yours?
Um, Boy, that's tough. I think I'm going to probably go with a Heath bar. I know it's not a popular favorite,
What's
but
the
that
heat
is
bar?
probably my favorite. It's
I don't know what
toffee
that is.
with chocolate on it. It's like
Okay.
English toffee with chocolate on it. Yeah.
I see. I see.
You know,
Okay. Okay.
I'm not too much of a candy person though, but come Halloween,
Either.
everyone's a candy person.
Absolutely. Do you have
Anyway,
pumpkins in the world?
I'm Damien. I'm your host. I'm here as usual with Nikola Marchik, CEO and co-founder of PolyAI, and today we're talking about power, something that's scary to many, but more specifically, how power fuels the next generation of AI and generative AI, simply because it uses so much. Now, we've talked about this in past episodes as well, just with regards to general consumption, but there's been a lot of activity in the news lately with some of the big tech companies and how they're pursuing alternate forms of energy to keep up with the demand that this, groundbreaking technology with its iterations and advancements is consuming with its compute needs. Microsoft obviously just announced that they are recommissioning 3 Mile Island to start under Constellation Energy's ownership to start doing some fusion power for their AI needs. Sam Altman has founded, or he's a chairman for a company that is Helion Energy, that is fusion based, and it's got like a 4 billion market cap. And then Google has worked with Kairos Energy to promise a handful um, of reactors here in the States. So obviously there's a lot of leaning towards nuclear. Why are so many tech companies looking at nuclear as opposed to some of the other more popular or iterative energy, especially on the renewable front, energy solutions out there?
Well, I mean, I think like first, if you just look at like the power considerations, right? We're building bigger and bigger models that are, well, they take a lot more energy and data to train, build, etc. Right? And then the main hypothesis that proved that, ushered in the era of LLMs is that, bigger models trained for longer and more data will perform better. That's kind of like played out, right? So I think the hypothesis that everyone's kind of like thinking about the future to say, hey, can we jack it up further, right? Can we have more data and, train for longer, more chips, and see where it leads us, right? So the needs of data center used to train a modern LLM is, a few months of, I don't know, the studio LA, right? So it's pretty serious.
Wow.
Right? Now, modern data centers are about 2 to 3%, I think, of global energy consumption. And
Okay.
AI will probably be the lion's share of that, like in 2 to 3 years from now, right? I'm not actually checking the numbers, but at this rate, it has to be, right? And when you think about that, it's like, okay, well, if you think that your competitive advantage, if you're Microsoft or any of the other big guys, right? You're like, okay, like, what do I need to fund the war effort? Well,
Right.
I need to have data. They all have a lot of data and they always work on having more and they synthesize and create a lot of data that they need to build the next generation of these things. So data on the one hand, right? They already have a data advantage, these few companies. Then you're like, okay, like, do I have the chips? And that's why NVIDIA skyrocketed. They're currently a monopoly and, in the foreseeable future, I think that they'll stay there. I was recently at a dinner where the CEO of an AI company said that he thinks that the only person who can stop AGI from arriving in about 3 to 5 years is Xi Jinping invading Taiwan, right? That otherwise, everything is already there, right? The hardware's coming, the data's there or being created, and we have like the algorithms.
Sure.
I don't know. I thought it was very
So just
expensive.
attack the supply line there, attack the production?
Well, I mean, if he were to do that, it would disrupt it. It would just delay it, right?
All
It's
right.
like, again, like we've talked about it many times. Like, what is AGI? How do you define it? What does it mean?
Yeah.
Different discussion, non-scientifically well-founded, infinitely fun to talk about, right?
Yeah, no doubt. For
So,
those of
so
for those of you not in the know, artificial general intelligence, check the episode, couple episodes back, give it a watch, and then come back and pick up.
yeah, absolutely. But look, I think that in that Cold War, I know funds, I know that a lot of the large, like Altman is like in the spotlight, so we hear about all this, but I think that many of the large public tech company CEOs have been buying up land that will be used for data centers quite well in advance, right? And it's like a thing that, it's like a fundamental part of the puzzle for, making greater use of AI, right? It's also like what kind of data center and where. Because if you have these clusters and you organize them in a certain place, you also need like concentrated power. So another interesting data point is that most of the energy used for AI today comes from non-renewables. It comes from
Right.
like
Cold gas.
coal, gas, oil, right?
Yeah.
Carbon, right? And, I know just like in prep for this room, you and I just looked, France is, I think, the only country which has the majority of its energy in nuclear, right? I think
Okay.
a lot of people, as tech people do, right? Like we think immediately, like, how do you scale it to infinity?
Right.
Well, nuclear is something that we can very predictably and reliably just like build more reactors, place them somewhere, hopefully they're good forever, right? And we'll have as much energy as we need, right?
But
So I think
obviously
that's the more,
nuclear has a little bit of a bad rep. You don't hear about solar accidents or solar panels causing, the sort of devastation that fallout from like the Chernobyl's and the 3 Mile Islands have. And so that's just something where it seems like it's got a bit of a marketing problem. Why is it that, I mean, even so much as to say that right now, nuclear power in the media and the headlines is being referred to as fusion energy because it's the same process. It just maybe has eschewing the old name and
rebrand,
ushering in
a
the new,
rebrand, right?
right? A total rebrand. So why is it, maybe not why, but does this sudden approach into a previously like somewhat taboo energy production system,
I don't think it's
maybe,
settled. It depends on where you look. I mean, America, what do we say? I think 20, no, close to 20% of U.S. energy comes from nuclear. So I don't
but
think
it's not
it's
out there like screaming it from the mountaintops. Again, it's got a consumer brand issue. It's got a consumer identity issue.
perhaps. I think that like it really depends on where you look, right?
Okay.
We're in the US is in the double digits, the UK is, France is at 70%, South Korea at 30. So, I think like it's just about what you have available, right?
Sure. Sure.
You have
I
a
guess
lot of like
I'm just saying
carbon.
there's a lot of efforts from the eco-conscious perspective of, preservation and renewable energies, solar, wind, water, all these like hydroelectric. It's just that seems to be the direction. If nuclear is the power du jour, largely driven by data center production needs, et cetera, does that put less eco-conscious nations like China, India on a more competitive standpoint from other
Look, I
nations who've
don't
been a bit
think,
hamstrung?
well, I don't think so. Not, I mean, like, yeah, we can like play a grand strategy game and say maybe, but the truth is the bottleneck is first and foremost hardware, right? And
Okay.
they're like, that's like foundational and the most like important bit right now. The second one is data. I think we've discussed previously how like a China could have a better grip over more of it in one place and concentrate that effort over the West. But equally, I think that we have these very large companies in the West already have formidable data advantages. And I think more advanced know-how in terms of how to create synthetic data. Although there, I don't think it's as far behind as it is in chip making. I think in terms of energy, well, these are well understood projects, right? So if that were the only bottleneck, I think that each, maybe not even large, like modern economy would know how to reinvest there, right? So there, I think if you don't have nuclear as an option, or you're unwilling to, right? I mean, my father-in-law would tell you that the Netherlands is insane for just stopping like natural gas production, which it has in like ample amounts, right? I think the UK is doing something similar where even that most, I think, well, the cleanest form of carbon has a bad rep, right? And I think that's purely a political issue. If it became
Sure. It's
central to
optics.
survival to have, you know, um, well, I don't know, Germany in the wake of like the Russo-Ukrainian war, like they've not turned on their nukes. In fact, they were notorious for turning them off as the whole thing was happening, and they saw like that the energy production in Germany will, well, that the equation is like irreversibly ruined by having more expensive energy, right?
Oh, okay.
So, I think that largely today still like Europe is heated over the winter through like LNG terminals from, America and the Middle East. So I don't know. It's interesting, right? I think that if it's 2 to 3% of our overall consumption and it's likely to grow, nuclear is an easy way to go about fixing it. But I don't think we're at a bottleneck yet. I just think that, these infrastructure investments are being made and people will make a lot of money if
Right.
they made them in time.
Well, so you've talked a little bit about, hey, this is one piece of the equation, right? When it comes to being competitive in the space, the other is hardware. It's the chips,
Yeah.
so pushing those aside, is there any other advancements in hardware, software that you think could help to tackle this potential energy crisis that could erupt by increased demand? Aside from the energy production piece, do you think there's anything else that could be done from a hardware software perspective to help to refine the energy needs of and the computing needs of generative right now?
Absolutely. I mean, look, the whole motion of training with more data and that being the main way that we produce technological advancement, like it's the most non-elegant thing that exists, right? It is brute force in its purest form, right? And the counter to that would be like, can we have algorithmic advancements, better models that learn faster, that, generalize faster, that use data more effectively, that, you're basically upping that learning rate. How can you learn faster, right?
Right.
Transformers were the last meaningful thing that really changed the course of deep learning, right? Like they eradicate the need to have like recurrent models and, more complicated cells. And it was fantastic that they worked, the work they did, right?
Right.
Now we're kind of at a point where, I would think, especially when you look at like the O1 model, like that's being furthered now with like hundreds, if not thousands of annotators who are creating examples of, data conversations and just like not necessarily conversations, but creating data in the right format at large scale for these models to learn from, right? I
Mhm.
think the latest estimate is that we've got a thing that's probably got an IQ of 120. Pretty serious. Like that's one deviation above average, right? Right. Smarter than what, like 70% of the people on the planet or something like that. Is that right? Yeah, something like that, right? So when you think about that, it's like, okay, like advancements might be able to come just from like better data. And if we don't have data structured in the right way, well, then we're not gonna get better things. Like the natural point of just like seeing more data, like it will flatten the curve, right? Now, the bet you can make is like, can we do it exponential yet again, right? Um, and I think a lot of people think that the current LLM without transformer would have just come 5, 10, 20 years later when the technology was just so much bigger, right? And the
Right.
first like deep learning advancements, modern deep learning advancements, you can like 2012 onwards, happened because, like we figured out how to train things on GPUs and to really just crank a lot more like iterations through, right? The
Mhm.
multi-layer perceptron, I think that's like 1967, right? I remember my, first bachelor's thesis and stuff. I remember support vector machines, Gaussian processes, and, that more hacky things like random forests. And it was quite diverse statistical machine learning back then, right? Like there
Right.
were a lot of things, and, it was kind of like if it was a computer game, you'd be choosing like, how mathematical do you want to be? Like, here's like a Gaussian process, which will give you decisions based on data it's trained on that are very explainable. You'll be able to break down the kernel of that process and see kind of like which factors, which features contributed to the decision that was made, right? So like I remember like predicting like diabetes. And I was like, well, weight matters, age matters,
Sure.
a few other things. Right? So, like that was interesting, but it was really weak because it wasn't a black box. It wasn't there to just get maximum performance. It was kind of like forcing itself to reason the way that a human would, right? So rather than just being predictive, it was trying to like really build a model that is like an interpretable model of why something works.
Kind of more
With deep learning,
rational.
we've thrown that into defying, right? They're
Okay.
at the other end. We're like,
Right.
these parameters, we don't know what they mean. They're a bunch of like sequential, nonlinear mathematical operations, and they produce text, and or they make decisions if they're trained as classifiers or whatever. They
Right.
rank the internet as usual. Um, So yeah, I think that we should really think about. Well, we should. We don't. Like we're just focused on solving our problems, right?
Right.
But you know, when we think about it, like it's really this like mix of like better data, better algorithms, and better hardware, right? Hardware really matters if you're going to consume a lot of data, right? So I think, for us internally, when we think about our data sets, they're crazily large from the perspective of like 5, 10 years ago, but they're not that large compared to what these people shoving nuclear reactors and, LA size data centers powering their training demands, right?
Right.
So, I think the best thing we can do for the environment is not do this. Now, of course, we're humans and we're capitalists and we're
Right.
greedy for
It's going to be done.
progress. When we compete, it will be done.
So
We
then that
don't until the shareholder stops believing
right.
or
Yeah.
whoever
Which will never
No,
fail.
I think it's very likely that if you saw like a flatlining or improvement, and you worked your Gartner, right? Like trough of disillusionment will come, and people nothing, right? But I think that while we see such shifts into um, models that can do a lot more than we ever believed was possible, people will be building data centers to jack it up, right?
Well, one of those things then, and this ushers in the power paradox, is can the reasoning and the advanced deep learning and the neural networks that are being demonstrated in current models, can they basically, and obviously AI, one of the chief applications for generative AI is in software development and coding, can basically it train itself to be as efficient as possible? And if not, can it basically map out the most efficient, from a physical perspective, the most efficient energy grid and sourcing that can be done to power its ever-growing needs?
I mean, look, I think that can AI be used to improve designs of these things? For sure. Can it do it itself? I mean, that's the eternal question of like singularity. If you're imagining like
True.
Skynet sitting there improving itself, sure, but if all you go after the French nuclear reactors and the American nuclear reactors first, right? Because they would claim the land and invade Taiwan and take all the GPUs, right?
Right.
Um,
There you go.
those would be it's
Say goodnight,
priority.
Xi Jinping. You lost your chance.
Well, right. But I think for real though, it's maybe, but like it's still gonna have a natural physical limitation. And if it's that demanding, it will spread geographically, it will spread, vertically, horizontally, and in every other way it can, right? So, scaling it by producing more energy and more chips and, that whole supply chain all the way from like real estate to like the raw materials all the way to like the land that it will be built on. And
Right.
I guess the regulatory environment which allows it to do all that.
Yeah.
I mean, like we're kind of doing it right now as a civilization, man.
Right. So the course is the course until it gets proven otherwise. Is that what I'm hearing from you?
Well, look, I mean, I think that we consume more and more technology. AI is the conduit. It's like the new thing that everything will be built on, right? So will that 3% of energy going into like AI training and stuff increase? Oh, for sure.
Increase. Yeah.
I think where will it like reach? Look, I mean, as you think about hopefully the age of abundance where we'll just, like watch Netflix and play computer games and pontificate, albeit in ways inferior to everything. Uh, mm, we'll probably consume a lot more entertainment, right? And if you think about what drove tech industry to produce the GPUs we have today, then a lot for AI, it's gaming, right? I mean, what was your first GPU? Do you remember? On a
My
computer?
first
Again,
GPU, I think it was a Texas Instruments Oh boy, I couldn't tell you the model. It was basically for word processing.
Hmm, okay, okay. Mine was a GeForce 2. I'm trying to see. I think it was an MX 400. But yeah, I mean, this is like, well, you can buy it for 100 pounds. This is basically like, cool. This is that's like a lot smaller and weaker than their modern variants, but like they were
Sure.
part of getting there, right? I
Right.
think again, like even if, the drive of the tech industry to produce better LLMs to give them a competitive advantage over others, like even if that thing comes down a little, we'll still be doing entertainment, right? And we'll be producing, right?
Yeah, I
So
guess
there are
that's
still
true. I guess
films.
that's true. So,
Yeah,
so maybe the energy isn't going towards other facilitated production, but it's going towards us feeding our natural need to always be entertained. And maybe we do have more of a Wall-E type future at that point, or we're just
yeah,
going
I
around our
mean,
own
look,
personal entertainment devices.
absolutely, right? So I think we'll need a lot of energy for whatever we. So it's probably not wasted, right? I don't know enough about the distribution, storage, and all that, but if you think about like just raw electricity production and like EVs, well, like it's not a bad thing that we're doing all this, right?
Right. All right. So we basically find another use for the energy that we end up saving by becoming more efficient, and we end up staying pretty much flat with regards to consumption, and it spikes anyway. So we're
Well,
we're
it's
building our own
and
failure
then
because of Netflix.
whatever's still left, you use it to train GPT-11
Right.
and or you mine Bitcoin, right? So
Yeah. Very, very true. Boy, that's another episode. All right. Cool. Well, thanks very much, Nikola. This was awesome to talk about. I love painting these futures with you. It's always interesting to see where we end up. And this time it was, what was your first GPU? Which is awesome. Now I'm going,
yeah,
I'm thinking back,
no hole in the
waxing,
company.
waxing historic.
Yeah,
I appreciate your time. A pleasure as always. And we'll talk to you next week. Okay.
yeah. Have a good one.
All right. Take care.